hang on, we're recording. Okay, so now on the left side, the derivative of u is technically 1 du, and the derivative of x to the fourth plus 8, Deli, is what is the derivative of x to the fourth plus 8?
4x cubed.
4x cubed. Beautiful. But next to it, we're going to put dx because we've taken du, dx, and we've separated it, putting our differentials derivative with respect to u on the left and the derivative with respect to x on the right. Now, so now we're going to look back at our problem. And notice 4x cubed dx is an expression. And it is right here in my actual integral, 4x cubed dx. So I can take 4x cubed dx and I can simply replace it with the expression du. So 4x cubed dx actually becomes du. Now, I also have another piece. Purple, make you nice, bright purple. That's the u part right here. X to the fourth plus 8 is being represented by u. So in my problem, do you see your x to the fourth plus 8? It's right here. So what you're going to do is you're going to go back to that integral, and instead of putting x to the fourth plus 8, we're simply going to take x to the fourth plus 8 and replace it with the letter u right here. So that's going to give us u raised to the fifth. And that's called u-substitution. You find an inside part, you take the derivative, but when you take the derivative, you're going to look at the differentials, keeping du on the left and du on the right, so you can make those straight up substitutions. Now, this is a piece of cake. Deli, do you want to finish this problem for me? What's the antiderivative of u to the fifth? It's what? Oh yeah, what do we do?
Is it u to the sixth? 1/6 u to the sixth?
Absolutely, it is 1/6 u to the sixth, 1000%. And because we didn't start with u's, we don't want to finish with u's. We want to finish with x's. So now we go back to our, this key wonderful substitution. What is u? U is being replaced with x to the fourth plus 8. U is replacing x to the fourth plus 8. So let's put it back in. And now we have x to the fourth plus 8 raised to the sixth plus c. Ta-da! We finish with something that looks really pretty and really nice. We started with this complicated composition and the derivative of the inside and the outside going on. But that is how we integrate problems that start out. It's kind of, what do you call it? Start out with it's the reverse of the chain rule. Yeah, what do I mean? There's a composition. To apply the derivative, we would take the chain rule, and then we would go back and get exactly what we started with. How are you guys with you? How many of you guys, give me a hands up, have you guys seen u-substitution in your previous Calc 1 classes? Most people have if they've taken Calc 1. Can I see hands up on that? So you guys have seen it? Oh yeah, we got some clapping going on. I love it. Jenna must love u-substitution. I love that. That is so awesome. You guys like u-sub? It's cool. It's such a good method. Okay, here we go. All right, are we ready? So, okay, let's do some u-substitutions. For the rest of whatever time we can, we're going to do u-subs. Okay, so now let's get a little complicated. Let's take it up a notch. But here we go. They're complicated, but it's okay because we're all in this together and we're all going to figure these out. All right, that first one, we got some sines and cosines, and then we've got some x's and square roots. We're going to go through these kind of slow together. You are welcome to work ahead if you want to, okay? We'll kind of go through these slow together, and then I'm going to give you a bunch to try on your own. But let me walk you through, and you guys go ahead. You're looking for two key things here. You are looking for, we have a composition, and in the composition, you have an inside function. So you are specifically looking for compositions with an inside function. That inside function is our g function, or we are going to call it our u. And you also want to look for a derivative of g being on the outside. derivative. I'm spelling it all wrong. So you're still looking for g prime of x on the outside. Okay, so sine to the 20th of x times the cosine of x. You guys see a composition. By the way, I'm going to rewrite this just so everybody knows. Sine raised to the 20th of x is sine of x to the 20th power. I'm not quite sure why mathematicians don't write it like that, because I think it's easier, but probably because of shorthand notation, they wrote it the other way. So let me see. I need somebody different to help me out here and give me a U for this one. Who wants to help me with a U?
I can.
All right, Nathan, go for it. Give me my U.
Your U is going to be sine of x.
Beautiful. Because why? How did you know it was sine of x?
Because it's the inside function.
Absolutely. U is sine of x because it's the inside function. You want to go through and tell me what du then is going to be?
Du is going to be cosine of x dx.
Perfect. Did I not tell you guys you got to memorize these? Got to memorize these sines and cosines, derivatives and tangents and secants. It's a necessity. Okay, good. Do you want to keep going? Do you want to finish this one for me, Nathan?
Sure.
Awesome, awesome, awesome.
All right, so you know that du is cosine of x dx, so it's just going to be u to the 20th du.
Awesome. This guy here is du. This guy here is u. So just like you said, it's u to the 20th du. Oh my God, so easy. Okay, go, 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 go.
All right, so once you know that, then you're going to take the antiderivative of that. So it's going to be 1 over 21 times sine of x to the 21st power.
Oh, you are so good. You
Plus
guys
c.
are way faster than me. Hang on. I'm going to have to do it in terms of u. Now you got replaced and you have sine of x to the 21st power plus c. Very nice. Thank you, thank you, thank you. Perfect, Nathan. Does anybody have questions? Oh, I just lost my thing. Why did I lose my thing? Are you guys still there with me? I just lost my Zoom session.
We're here.
Oh, that was so weird. Okay, give me a second. Why can't I see you guys anymore? I will be right back. Stay here. Everybody stay here or work the next problem. I will be right back. Okay, guys? I have to exit and I have to come back. Oh, we all have to come back now. Darn it. Hang on, back to meeting. Oh, there I am. Okay, I'm still here. Okay, you guys still here? Okay, I'm still here. Sorry about that. It does weird things. I think the recording got finished and so it sent me a message and logged me off. Okay, anyways. Okay, somebody different. Who wants to try this second example B? X times the square root of x squared plus 5. Anybody want to try this one and walk me through what u's going to be? Who hasn't talked yet? Who hasn't talked yet that feels like, okay, we're going to try this one. I'm going to tell Tina how to do this one. Taylor, go for it.
So is u gonna be the x squared plus 5?
It is. U is absolutely
Because
going
it's
to
the
be x
inside.
squared plus 5. Good.
And then du is the x dx.
So derivative of x squared plus 5. So derivative of x squared is 2x.
Yeah, 2x.
2x dx. Because the
2x.
derivative of x squared is bring the power down, right? 2x. And derivative of the constant 0. Beautiful. Beautiful, Taylor. That is so perfect. Hang on. While you're doing, well, before you talk anymore, I'm going to go forward and I'm going to put this here and write this as x times x squared plus 5 to the 1/2. And I'm going to do one more thing quick. I'm actually going to change my order. You don't have to, but sometimes this helps people see this better. Now, at this point, okay, so I just moved my x and sat it right next to my dx, so I saw that pattern right there. Do you see what I did? Now, this one is a hair more complicated. The reason it's a hair more complicated is my original expression doesn't have a 2. Do you see that? It's missing the 2 in the original integral. Now, I don't know how other teachers teach u-substitution with this, but I tend to do this. I see x dx appearing here and here. So I say to myself, I want to have x dx by itself. So I like to multiply both sides of this equation by a half. Why do I do that? I do that because that brings the x dx to be a single entity, a quantity all by itself. And that 2 now is put over there next to the 1/2 du. And now I make my straight up substitution. Does everybody see this? It's just, so we have an inside function, which is x squared plus 5. The derivative is 2x dx. There's no 2 here, right? But that's okay, because we can deal with it. What's most important is we have that x piece. Does that make sense? Taylor, do you want to keep going with me and just take a gamble here? X squared plus 5 is going to get replaced with what? With u, right?
Yeah.
So we would write that as u to the 1/2. And then the x dx, if we do it my way, but everybody can do it their own way if they learned a different way, okay? X dx would then get replaced with 1/2 du. Do you see that? Now, we have another rule that I haven't emphasized or talked a lot about, and it's a good opportunity to talk about this right now. If you have things that are all getting multiplied, see how it's all getting multiplied? Taylor, tell me, nod your head if this makes sense. Did you learn this rule that you can take that coefficient and just throw it out front? Did you learn that? I tend to do, good. So I tend to do that. If everything's multiplied and I simply have that number or the numeric coefficient, you're going to see me always bringing it out front because it makes my integral simpler to work with. And so now we're going to keep going. And I think I'm going to do one more thing while I'm doing this. I'm going to change my background. There we go. Okay, so now I'm going to keep going here. And Taylor, you want to finish me off with this antiderivative? What's it going to be? Oh, are you muted, Taylor? I'm sorry.
So would it be,
Yep.
you just substitute what we had for u in, right?
Yep. Well, so now we're
So
going
it'd
to
be-
take the antiderivative first. What's the antiderivative of u to the 1/2?
I don't know.
It's okay. It's okay. It's okay. You know what? When you get put on the spot, your brain goes, I know my brain goes 1000%. We're going to get a friend right now. We're phoning a friend. Okay. Anybody want a friend in? Can somebody help me and Taylor finish this here?
If you will excuse slightly crowded audio, I would love to help.
Go ahead, Alex. You're in the hallway, right? Can you help out Taylor here? What are we going to do with this 1/2? The u to the 1/2.
The 1/2, you don't take the integral, you just multiply it to the. Oh, no, you mean the 1/2 as you mean the 1/2 on the outside, or the 1/2 as the that we're taking the integral of the u with.
Okay. You just tell me what your brain is saying. You're right. There's a 1/2 in front, right?
What I did basically was, so that 1/2, you're going to use it to take the integral of the u.
Okay.
Therefore, giving you 1/2 times 2u to the 3/2 over 3, which,
Okay.
by the way, then you can just get rid of both the 2's.
Okay, you went fast. Okay, so first thing is
Sorry.
you took u to the 1/2 and you added 1, which gave me u to the 3/2, correct?
Yeah.
And then
honestly,
you
a trick
took
I
that
did-
u to the 3/2 and then you turned and inverted it and made it 2/3 in front.
Yes.
And you kept that 1/2 in front of that integral and just multiplied it through.
That's
And
correct.
so then you said, hang on, this is what you just
Oh,
jumped
yeah,
to.
n plus c.
You got that to be, because those 2 cancels, I'm just making sure I'm going through what you said. That's 1/3 u to the 3/2 plus c. Is that correct?
That's yeah.
And then you replace the u. Are we good, Taylor? Yeah? Are we good? You see that? Awesome. Beautiful. Taylor, replace that for me. What are we replacing u with? And tell me what we get. 1/3 times. What
Who are
is
you
our
asking?
Taylor? I'm going to have Taylor help me out here now. So 1/3 times. Thank you, Alex. Thank you.
X squared plus 5.
Okay, yes, there it is. Sorry, I lost it there for a second. I didn't see it. Yep, you're right. U is x squared plus 5. Beautiful. And
To
then
the
that
3
gets
halves
raised to the 3/2. Thank you. Plus C.
plus C.
Thank you, Taylor. Thank you, Alex. That was gorgeous. That is gorgeous. Now look how simple it is. It's much simpler at the bottom than it was at the top. And that's what happens with these chain rules and U substitutions. How are you guys feeling? How we doing with USub? Are you like, oh my God, Tina, it's this easy? Super easy. All right. I've got some you try exercises, okay? That means I'm not going to even help you out at the beginning. I'm going to let you guys work on it for a couple minutes. So our next, oh, hang on 1 second. Stop, Tina, going way too fast. Does anybody have questions? Is there anybody who needed a question with any of the steps that we did? Practice makes perfect on these. You just got to practice them. Anybody have questions at all? Okay, if there are no questions, then we are going to go to these two you try exercises. So the first one is find the indefinite integral on the left of 4x times 5 minus 3x squared raised to the 10th. You're going to have coefficients, the numbers not quite matching, but what you should do is be able to find an inside function, let that be u, and then the derivative. And then that second integral is a little ugly looking, but again, focus on the composition piece, take the inside, let that be u, and then the derivative should fall out for you. I am telling you, both of these are u substitution problems. You want to start getting used to being able to see the pattern, but first we just have to practice the method before we can recognize the pattern. So I'm going to go silent and let you guys work these for a minute or two, and then we'll have new people help us out, okay? Guys want a little more time or how we doing? If you guys are finished, give me some thumbs up so I can see that you guys have worked these through. If you're finished. So the rest of you guys just keep working for, I see we need a little minute, another minute or so. Maybe 30 seconds. Okay, all righty. I need some new people who haven't talked yet, who hasn't had a chance to talk. Would anybody who hasn't had a chance to talk yet like to volunteer and walk through the U try exercise A? Anyone want to go ahead? Jacob, go for it.
All right, so I started by letting u equal 5 minus 3x squared,
Perfect.
and then I took the derivative of that, so it's du equals negative 6x dx.
I love it.
And then I took the inverse on the other side, so it's negative 1/6 du is equal to x dx.
Perfect.
And then so I did negative 1/6 times 4. I took the 4 out of the x in the integral. And then so I brought those to the outside of the integral, and then I just had u to the 10th du on the inside.
Mm-hmm.
And then next, so I multiplied the 4 and the negative 1/6 on the outside, so it's negative 2/3, and then the integral of u to the 10th is 1 over 11th times u to the 11th du. And then I multiplied the negative 2/3 and the 1/11th, and then that's negative 2 over 33. And I plugged the u back in, so it's 5 minus 3x squared to the 11th plus c.
Perfect. Perfect. Couldn't have spoken it any better. Perfect. Good job. Very nice. Thank you. Thanks, Jacob. Thanks. Okay, I need somebody else who hasn't done anything yet. Help me out here. I need this B. Okay, now this is the doozy. I'll tell you what. Why? Because it's got a natural log in it. Who wants to help? Who wants to go on this one? And it doesn't have to be perfect. Doesn't matter. We are learning. We are students of life. Somebody who didn't talk. Volunteer. Anybody? So I know who talked and who didn't talk, and I could just pick people, but I don't want to do that. I just don't like to pick people right now, right at the beginning of class. So anybody want to go ahead and say, I got this, Tina, or I'm not quite sure, but we're gonna give it a shot. Who hasn't talked yet? Anyone? Okay, somebody that has done, oh, Jenna, go ahead, Jenna.
Okay, so for u, I said that it would equal 3 natural log of y plus 5.
Beautiful.
And then the derivative of that, so du equals 3 over y dy.
Mm-hmm.
And then I just multiplied both sides by 1/3.
Beautiful.
So then with the integral, I rewrote it by putting 1/3 outside.
Okay.
And then on the inside, I did u to the 8th du.
Perfect. And I'm going to stop and put a little extra step in here because this integral that we started with, just to make it clear, just in case there are some people that weren't quite sure, that y on the bottom is actually like 1 over y dy. So that's where you came from with that. Perfect. Good. Okay. And then you finish it up for me.
And then the integral of that, I did 1/3 times 1/9
Mm-hmm.
times u to the 9th
Mm-hmm.
plus c.
Mm-hmm.
And then I plugged u back in and simplified or multiplied the fractions to get 1/27th times the quantity of 3 natural log of y plus 5 to the 9th plus c.
I love it. I love it, love it, love it. Beautiful. Perfect. Yay. Good job. Good job. Very nice. Okay. All right, guys. So let's see. We're getting close to, let me see. I got 12:10. So we got less than 12 minutes. And then this time the Zoom thing runs out at 6. So what I want to do, anybody have questions on these two problems that we have up here? Make sure you take a screenshot or whatever if you do, if you didn't quite get it, and we can look back at it later. Are there any questions, though, quickly on either of these problems? I want to jump ahead to the challenge exercises, if that's okay with everyone. So I do have, as part of the notes, 2 more problems. We're not going to do these. I'll let you try these at home, okay? Because I do want to move ahead to something that's a little more challenging. But again, on each of these, make sure you let u be the innermost piece and then the outermost piece. And let me do one thing, though, on this C to give you just a quick hint on C. Well, I can show you. Remember, you can always look at it this way, where that thing on the bottom is multiplied times the rest. So I'll just put it that way, throw it out there and let you guys look at it. If you have questions, come and see me next week and we'll talk about it too in class on Monday. That being said, I do want to get to these couple examples. Challenging. They're just a hair more challenging, a little more difficult. So let's take a look at this challenging example right here. Why do I say it's more challenging? It's more challenging because in this specific case, I have a composition, but notice in this composition, if I was to take and let u be the innermost piece, I would be letting u equal 6 minus x, which is the innermost piece on this composition. Do you see that? The problem is, in this really challenging example, if you let u be the inner piece, what happens to the derivative? The derivative is just negative dx. And what happens is this little extra piece here gets lost in the process. Do you guys see what I'm saying? So it's a composition, but the derivative is not there, that little x at the end. So this is what we call a really challenging and special exercise. I think you have one of these on your homework. If I looked, you have one of these. In this case, I just want to give a hint, and I want to have you guys kind of walk through it and think through this. But the hint for this guy here is that you need to replace an x and your hint for this thing here is you're going to use algebra to solve for x. So if I have u equals 6 minus x, and I solve for x, I would do some algebra here. And I would say, if I want to get x by itself, I'm going to add x to both sides. And then I'm going to subtract u. And so in this particular problem, even though it's not a direct chain rule problem, it can be solved using u-substitution by taking the x and replacing the x with 6 minus u. Then you would multiply and we'd finish it out. But I did want to show you that before our time runs out, that's a little trick. And again, you're not going to follow it right now because you're just seeing it, but you're going to want to work it through with your hands and work it through with your brain and finish that problem and work that through, because you're going to multiply through, because u to the 4th times u gives us u to the 5th. And then you would finish it. You take the antiderivative and go down. So this is an example where you have an exercise that's you can't quite see necessarily. There's one more challenging problem I want to just throw up there to give you a hint. And that's this one here. And you're like, oh my God, Tina, are you kidding me? You're going to give us a problem like that on our homework? Well, I didn't pick the homework problems. The department picked the homework problems. I just kind of go with it. But no, it's a good problem. It's still a good problem. But there's so much going on in this problem. Sometimes it's hard to figure out what u is going to be.
I got a question.
Yeah, Alex, go ahead.
Couldn't you technically simplify the bottom to sine of 3x? Sine squared 3x, I mean?
Oh, I love it. I know what you're doing. You're doing sine squared plus cosine squared is 1.
Yeah.
And so sine squared could get replaced with 1 minus cosine squared. So our problem is the sine. We can't put that together. That can't become sine squared. Good
It'll
thinking,
become
though.
negative sine squared?
If it was a negative in there, then we could replace it and then we could move forward. So for this one, you would want to do a u substitution. And I'm going to say let u be cosine of 3x. And the reason I would choose that is I see that that's the innermost piece, and the derivative also happens to be in the problem. Negative sine 3x.